Welcome to yet another episode of the New Ventures podcast. Our guest for today is Adrian Bukmanis, founder of Veridian Refrigerant Management. And your host is Sanjoy Sanyal. I am the founder of a boutique clean tech consulting firm, Regain Paradise, and also a visiting fellow at the Cambridge Judge Business School. Welcome, Adrian.
Thank you, Sanjoy. It's a pleasure to be here, and thank you very much for the invitation to speak with you today.
Before we start business, I have to ask you this question. You started your first company in Singapore, and I was looking at your profile after traveling the whole world. What is it about your journey and your first impressions of Singapore?
Certainly, I've been very fortunate to have traveled widely. I'm a little bit more, let's say, aware of the impact now, but before I came to Singapore, I had the opportunity to see a lot of places, and I've been very grateful for that. Maybe just as a little bit of backstory, I grew up in Australia and was originally working in IT and data communications. I did like a lot of Australians and spent some time in the UK and London. I worked for some companies there. I had the opportunity to work with Lehman Brothers before they went bust, which was really interesting time working in IT. But I also was looking for a bit of a change, and I ended up working in motorsport, of all things. And I'm also aware of the correlation between climate and motorsport. But at the time, it was a rare opportunity. I was looking after customers across a lot of the world in the Middle East, the Balkans, Asia, and China. So I got to see a lot of places off the normal tourist trail. I got to meet lots of interesting people. And it was during that time that I began to understand how data is used to improve performance of systems. There's a lot of data analysis that happens in motorsport. And that's partly what led me to Singapore and to start the business there. But Singapore's been fantastic. It's a great cultural mix. It's a great place to start a business, and been really fortunate to spend over a decade, or close to a decade there.
Wonderful. Which brings me to the question about Teal, the company that you founded in Singapore. How does it use data, and in what context?
Mm-hmm. So the primary motivation for Teal was to improve energy performance. So reducing emissions and reducing costs by monitoring energy and building systems. And maybe a good way to look at that, or to think of it, is also to use that motorsport analogy. As even if you don't follow Formula One, maybe you've seen photos of pit stop, and you'll see lots of people looking at screens of data, and there's engineers and there's team principals and even the drivers. It's very much a data orientated process, and it's a simple formula of taking data plus good engineering equals high performance. And that's kind of what we started doing at Teal, is to apply that to buildings and industrial facilities. And one way that people look at that is to go and develop new software. But we started almost early 2011. But even at that time, there was still lots of really good software around globally. It's just that there perhaps weren't the skills or the engineering side to implement it properly. So that's what we focused on. So taking software tools that were available, but bringing the skill set to apply them for commercial and industrial properties, with the intention of improving energy efficiency and driving energy retrofits. And that was the whole foundation of Teal, and still what we focus on today.
That's great. Obviously, one of the most interesting things to talk about is how your customers use your product. So I know you have customers in various segments: educational institutions, industrial facilities. Can you give us a few examples?
Certainly. We've been really fortunate to work across lots and lots of different sectors. For me, industrial has always been the more interesting, because you tend to come across lots and lots of different types of systems, from compressed air to boilers to processing lines and so forth. But where we've often made the biggest difference is by finding customers that are ready to act on the findings. And I think this is a really key thing, is because if the customers aren't prepared to act on what is discovered by the software, or even through a traditional energy audit system, then you might end up with a really nice technology project. You might end up with nice visualizations and dashboards and metrics. But at the end, if the client isn't willing to move forward with the recommendations, then you're really not getting the maximum benefit from the process. So it maybe took a little bit of time to come to that realization, but it's a really important one. So in the end, we tried to find those types of customers that understood that it's a tool. It's a tool in the toolbox for moving forward and driving whether it's deep retrofit projects or other types of energy efficiency projects. But those types of customers were the ones that we really enjoyed working with. But for me personally, as I said, industrial systems, compressed air systems, they were some of the systems I really liked to work with down the years. And there were some customers where we delivered really large energy savings in short periods of time, 6 to 12 months. But there was also other customers that would use it just for visibility or transparency, for contractor management or emissions reporting or supporting ISO 50001, for example. So there's lots of different ways in which clients would get value from the type of work that we would do.
I think the point that you mentioned about customers being really ready to use the product is a very important. In these type of technology solutions, customers really need to be vested into the deployment. But I was also curious to understand, when you say industrial facility, are they in Singapore or are they in the region? Can you give us a few examples?
So a bit of both. A lot of the work we did was in Singapore. But for example, we did manufacturing facilities in Malaysia and Thailand, breweries in Vietnam, even as far afield as Africa. Did a project in Ghana. Singapore was fantastic because you've got such a compact location with lots of facilities there. But certainly I enjoyed visiting some of the other locations in Southeast Asia, especially.
Right. And for some of our audience who are not necessarily that familiar with Singapore, maybe you can just comment a little bit on Singapore's industrial base, because people may not really get that.
Yeah, it's a good point as well, because even if you visited Singapore as a tourist, you've probably gone from the airport to the city and everything is tree lined and let's say tourist friendly. But perhaps on the other side of Singapore, you've got Jurong Island, which is one of the world's biggest refining and petrochemical facilities. Further afield, you've got all types of manufacturing, from heavy industry through to semiconductors, through to even solar panel manufacturing, through to seafood processing. You've got everything. There's all sorts of really interesting industrial facilities within Singapore, and that was something that I really enjoyed, because even for a small location, there is lots and lots of different types of facilities, and I was really enjoyed going to visit as many of those as I could.
Exactly. And now you are onto your another venture, which is deep diving into one specific use of energy, that is in cooling. Perhaps before we talk about that business, it'd be nice if you could explain the importance of this topic in global warming.
Certainly, and it's a big, broad, all-encompassing topic. I think even if most people were to look around, they would start to identify places where refrigerants are used, but maybe some that they might not think about. But even just for headline numbers, the cooling sector is generally accepted to be responsible for 7% of global emissions. That's both energy and also the refrigerant gases. The refrigerant gases themselves are maybe 2 to 3% of global emissions annually. But one of the important things is they're the fastest growing source of greenhouse gas emissions. And most people are aware of carbon dioxide. Some people are aware of methane, which is also important. But this group called fluorinated gases, or F gases, of which refrigerants are the largest contributor, are the fastest grower. They're the fastest growing sector. So that's one thing that makes them important. But they're also everywhere. They're in obviously your refrigerator, but also in your vehicle. They're in the data center, the telecoms towers, obviously the cold chain, refrigerated shipping containers. There's refrigerants everywhere throughout the global supply chains, in most people's premises, in their offices. They're absolutely everywhere, but most people don't get to see them. So they're invisible gas that's doing lots of work in cooling, sometimes heating as well in heat pumps. But the problem is they leak, and when they leak, they go to the atmosphere. And most refrigerants are like carbon dioxide on steroids. Many of the refrigerants are about 1,000 times more potent than carbon dioxide as a greenhouse gas. They're what's called a super pollutant. They don't last in the atmosphere as long as carbon dioxide, but they contribute a significant amount to global warming, and they get very little attention. One of the interesting things is, if anybody is familiar with Project Drawdown, which was a set of solutions or climate solutions released a few years ago, it was the number one climate solution, and this was in front of wind and solar and preserving tropical forests and so forth, and all these other really important things. But it just goes to show how important, but also how little attention it's received since then. So it's a really important one. And obviously, there's a bit of a vicious cycle in that. I think we're seeing it in the news at the moment, is that as the climate warms, the need for cooling increases, but by increasing our cooling equipment, so air conditioners and so forth, we use more energy, we release more refrigerants into the atmosphere, and it creates a vicious cycle. And that's why I believe it needs more attention. So I'm, let's say, doubling down and focusing on that particular sector at the moment.
Right. I really like the point that you mentioned about refrigerant gases being carbon dioxide on steroids, because that's exactly what it is. I mean, they live in the atmosphere for a relatively shorter period, but the harm they can cause in terms of global warming potential is far larger. And I did not know that actually it is the top solution that was proposed by Project Drawdown. That's a very important point as well. One thing that you mentioned is that refrigerants are everywhere. So perhaps I would like to start asking about your business by asking who will be your target customers.
Yeah, having said that, because they're everywhere, you could certainly suggest that it's important for all businesses to consider it. But certainly there's more that are, let's say, our initial targets. And when we look at the benefits of managing refrigerants specifically, obviously emissions is one of those, but there's also cost. There's a safety aspect because some refrigerants are toxic. So there's a safety element to that. There's the end product. If you're processing food or concerned about food waste, then that's one other element. And I guess risk management goes across all of those. So we're looking for, let's say, specific customers that are aware of those challenges, but also those benefits. We're also looking at customers that have potentially high leak rates. So good examples of that are, say, supermarkets, because they have long, let's say, refrigerant lines. They're field manufactured, so they tend to leak quite significantly. But also, say, companies operating large vehicle fleets. I think even most of us, certainly being in tropics or warmer climates, would have experienced the car air conditioning not performing as well as it should. So you take it to the garage and normally they put some more refrigerant in and off you go again, without a second thought to the refrigerant gas that's just leaked to the atmosphere. And with billions of cars on the road, that's something that happens quite a lot. So the transportation fleets are also another really big source of refrigerant emissions. So in short, we're looking at lots of different sectors at the moment, but we're also targeting those that specifically looking at net zero or have net zero targets, because at the end of the day, zero is zero. So even if refrigerant gases are maybe only 2 to 3% of, let's say, a company's emissions, is if we're getting to zero, then you have to, there's no choice to also address those 2 to 3%. So they're the type of clients we're working with.
And what type of services would you be providing these clients?
So we're working across, let's say, 3 primary areas. And the first one's a little bit boring in that it's you can think of it just like basic accounting. And anybody, I guess, that's worked in business understands the principle of accounting. And even though you might not like to do it and it's not your first priority, it's a really important element. So the first thing is to account for all the refrigerant that's within your care or under your operation. So that's understanding the assets that it's installed in, whether that's the air conditioners, the vehicles, the refrigerated shipping containers. So tracking those assets, tracking how much refrigerant is in them and how much is leaking. And we use software to do that. So there's a technology that underpins that process, but it's a service as well as a technology offering. So we call it refrigerant accounting or refrigerant management. The second aspect is looking at mitigating leaks. So once you're accounting for your refrigerant, you generally start to understand which systems are leaking. And then we can also apply technology to assist with leaking systems. One of those that we use is a climate check, which has been described previously on the podcast. And that's an important tool for monitoring and optimizing systems and also for detecting leaks. We can also use data analytics. We do that with Teal, looking at rules-based and also machine learning-based detection of leak conditions. But the other thing is when systems leak, they also use more energy. If you just take a simple rule of thumb that if you lose half the refrigerant in a system, you generally lose half the energy performance. So you consume twice as much energy potentially. If you lose refrigerant, you also have increased wear on the system. You have higher maintenance costs. So by mitigating leaks, you're saving money from refrigerant, from the energy use, from the maintenance, you're reducing obviously the safety risks, the compliance risks. There was an example, certainly in some locations where you've got leaks, there's certain penalties around those as well. So there's lots of benefits for keeping the leaks under control. And the third area is around advisory and training. So we work with companies to help mitigate those risks, both from, let's say, an operating standpoint, but also from a competitive. I mentioned in the US, they have a program called Green Chill. So there's certain supermarkets that are using, let's say, low polluting refrigerants, and they have a competitive advantage to other retailers. So we help guide customers on that journey. There's lots of regulation being discussed and some being implemented. So we help advise customers on that to stay ahead of the curve so that they can mitigate those risks. So they're saving money and also mitigating risks. As part of that, we're also training and building capabilities, because that's an important part. If we're going to move the needle, we also need skills. So we're working on improving the skills for technicians to both be aware of the impact, but also being able to use natural refrigerants and low polluting refrigerants as well. That's a very important aspect.
Thank you. I think we will get into a fair amount of detail here. Perhaps the best place to start is to just get rid of some terminology. One of the terminologies that many of our audience would be familiar with is this term called HFCs. Then you have used the word natural refrigerants or low polluting refrigerants. Perhaps if you can help us understand the sort of entire field of refrigerants.
Certainly, there's lots of avenues to take, but I'll try and keep it as simple as possible. I guess a number of people might be familiar with the problem that surrounded the ozone layer, and this was going back in, let's say, the 80s and 90s, around refrigerants called CFCs or chlorofluorocarbons, what we call sort of the second generation of refrigerants. And they came under they were effectively banned and replaced by HFCs, as you mentioned, hydrofluorocarbons. And they don't impact the ozone layer, but they have a problem with global warming. They basically absorb heat and they contribute to the warming of the atmosphere. So HFCs are a problem. And so now there's this fourth generation of refrigerants. And some of these refrigerants are still man-made, what we call synthetic refrigerants. And even though they have a low global warming potential, even though they might not deplete the ozone layer, they perhaps have other environmental impacts. They still are man-made chemicals. Some of them potentially fall into what are called PFAs or forever chemicals, which potentially build up in our drinking water. So by continuing to use synthetic man-made refrigerants, we're still likely to have a problem going forward. So there is a group of refrigerants called natural refrigerants, which aren't perfect, but they are found naturally in our environment. So those are air and water you can use as refrigerants. Interestingly enough, carbon dioxide you can use as a refrigerant, and it's actually getting more and more common. Propane is also another refrigerant that is becoming more common. And most people would probably not know, but most refrigerators now built in say, Europe, for example, use butane, has been for many years now. So they're generally what we refer to as natural refrigerants. Ammonia is another one there as well. So all of them have some particular drawbacks. Some are flammable, some are slightly toxic. But because they're generally found in nature, we're not expecting to see the problems we have with synthetic refrigerants going forward. So at the moment, they're generally accepted as being our best bet and the most future-proof set of refrigerants that we can use.
And that's very useful. So then the other thing that I wanted to get down is the way you provide the services. So I think, and it's particular the point that you made about using software. For creating inventory, you have a software application. And for managing leaks, you use a software of Climate Check. Obviously, you've been hearing our podcast very closely because that's a European company.
Yeah, British.
I'm very keen to understand, you mentioned something at the beginning of the podcast that you used software developed by others and applied it to problems. Do you sort of bring the same philosophy here, or did you have to develop new software?
Yes, I still tend to follow that approach. I come from an IT background, so part of me thinks, well, I think what's really struck me is there is lots of software out there, and there's lots of companies that are just focused on that. But there's also really, really underserved need for companies that know how to implement it and can also interpret it and know how to apply it to get the results. Because the software companies themselves, that's not necessarily their strength. And maybe traditional engineering companies don't have a background in IT and technology. For me, I still think that's a reasonable and an effective approach. The thing is it perhaps doesn't get all the attention because everybody likes to see a new app or a new piece of software written, and investors get excited and all the rest of it. But I think if you take a step back and you look at the urgency that we have now and the speed at which we need to get things done, we need to use the tools that are around us now. And there's lots of tools, there's lots of great software out there, there's lots of great best practice that's already been developed. We just need to do it. That's really my philosophy at the moment.
And that's an important point, because even in so-called enterprise software, and in the world you came from earlier on, there are very large companies which just specialize in implementing software. They are implementation partners of the software product companies, and that's a very reasonable way to build a business.
Yeah, and it's maybe not always the most exciting way, but I think it's also very effective. And as I said, I think when you're talking about urgency, I think that's the way to get things done.
Right. And then the third topic, which I wanted to get down into a little bit of detail, is, what is driving the market? For example, many of our audience would have heard of this term called Kigali Protocol, which basically is a step forward for withdrawing of HFCs from the market, correct?
Yes.
And so how important are those international collaborations?
They're absolutely vital, but at the same time, they're not enough on their own. So maybe just to take a step back. So just for clarity, the Kigali Amendment to the Montreal Protocol is specifically designed to phase down HFC production and consumption over the next 20 or so years, 20, 30 years. And without it, we'd be on a much worse path. That's absolutely a given. So the fact that it's been put together is a great start. The thing is, at the moment, is not every country has signed up to it or ratified it. About 131 have now ratified it, but we need everybody on board. But that's certainly one of the big drivers, because that's changing the way manufacturers and producers, the type of gases that they're going to put onto the market. And China has recently come on board, so that's a great step, because they're one of the biggest producers. So Kigali Amendment is one of those. But we're also seeing that then trickle down, and in the EU, you've got the EU F-gas regulations, which is now, there's been some new proposals just come out, which is even more aggressive in terms of phasing out HFC refrigerants. The US has started implementing through the AIM Act, which is really important. And even just a couple of weeks ago, the Securities Exchange Commission in the US brought out some proposals for companies suggesting or basically recommending that they disclose all their greenhouse gases, including HFCs and refrigerants. So that would be a game changer in the US. So all of that is starting to trickle down. And we know in Singapore, they're starting to look at HFCs more seriously now as well. So these are all starting to build up. And we're starting to see more sort of attention being paid to that. It also introduces lots of other interesting, you could say, side effects. One of the things that's been seen in Europe with the F-gas regulations is, as you start to reduce the quotas, so that's the amount of HFCs that are available on the market, is obviously the scarcity, they become more scarce. So that drives an illegal trade. And there's some estimates at the moment that maybe 20 to 30% of the refrigerants in Europe are smuggled in illegally to get around the quotas. And obviously those emissions don't get accounted for either. So there's implications around that. They're starting to look at ways of sort of closing off those avenues, but it's still very much a problem today. So even with the regulation, there are other considerations and things that need to be taken into account. And just one final point on that is, there was a recent paper that came out that said even with the Kigali framework, it's still not enough to reach the 1.5 degree targets that we're looking at under the Paris Agreement. So it's a good start and it's really aggressive, but it's still not enough. So again, this is why we're really pushing hard on this particular subject.
So when you're talking about refrigerants getting smuggled in, my automatic reaction is maybe there's not sufficient capacity of producing those natural refrigerants that you are talking about. Is that the cause, or what is the problem?
Yeah, that's a really good point as well. Yes, there are alternatives. That's the whole idea behind the reductions, is that by making HFCs more scarce, it should drive the transition to other types of refrigerants, Yeah, that's the premise for the regulations, and in principle it works. However, there's a lot of status quo, or certain companies have just been dealing with HFCs for the last decade. That's the way all their systems and their employees are trained and so forth. So it's easier to continue with the way you've done things in the past. I think the EU did recognize this early on. They put a lot of emphasis on trying to train technicians in using natural and alternative refrigerants, and generally they have trained a lot of people, but it's still not enough. That's the short answer. So, which is why, as part of our service offering, training is a critical component as well, is that if we are going to shift away from HFCs, if we're going to get around these problems with illegal refrigerants, there has to be an aware, capable, well-skilled workforce as well. And I know that's easier to say than perhaps do, but it is something that I think most people are aware of, and something that we are trying to influence as well.
Good point. But moving away from sort of international policy dialogue to your customers, it seems to me that your customers are being driven to come to you from three different standpoints. One is that they could be in a geography which is being regulated, for example, the European Union, or they could be having their net zero targets. Zero is zero, as you said. But it also seemed to me, because you said something earlier, that as you reduce leaks, you reduce energy use. So there is an economic benefit as well. So I'm just trying to figure out, among these three drivers, or maybe there are others, which one is the most important one?
For me, I like to think it's emissions, and those that are driven by reducing emissions without being pushed. So they're doing it for the right reasons, because if you're just doing it for compliance, if your heart's not really in it, for sure, we'll work with those types of clients. But it comes back to what I said earlier as well, when dealing with energy efficiency and Teal as well. You're more effective with customers that really understand and really want to get things done, that are willing to put the resources, to do the hard yards, to make a difference, because it's tough. And once you've done the low-hanging fruit, energy efficiency is tough. And managing refrigerants, it's not on many people's radar. You've got assets all over the place. Nobody knows what's in these assets. The awareness is low. So it's difficult, but if a company is genuine in hitting a net zero target, if they're aligned with the science, if they're not just relying on offsets to buy them time, then they're the type of companies we want to work with, because we can genuinely make a difference with those types of organizations.
Let me ask you this question from an investor's perspective. And I'm wondering, where should investors think of targeting their money? In the upgradation of the facilities of your customers, or they should be targeting the money in the upgradation of the manufacturing facilities of the new types of refrigerants? Perhaps both, right?
Yes, and a good question. For sure, it's happening on a couple of fronts. I could also point out some work that, say, for example, GIZ in Germany are doing, the ProClima team. They're helping manufacturers to change their production lines across to natural refrigerants. So they're already working on those types of avenues. Now, it also needs the market to shift. It needs consumers to be aware and to say, okay, I have a choice of two air conditioners. Which one am I going to purchase? And if you don't know anything about refrigerants or the impact, probably buy the one with the lowest cost. So yes, it's got to come both from that side. But the big gap at the moment when it comes to investment is what to do with these refrigerants at the end of life. So we can invest in mitigating leaks. We can invest in managing them while under our care. Problem is that a refrigerant that gets produced today goes into a system that maybe runs for 10 to 15 years. So in 15 years' time, I think we can all agree that this particular problem is going to be even bigger than we have today. And we've got all this refrigerant, and there's millions and millions of tons of it out there, what we call refrigerant banks, and it can't go into the atmosphere. So something has to happen with it, and who's going to pay for it? And that's the big challenge at the moment. And some of it you can deal with through offsets. And generally, I'm not a fan of offsets, but I think that's maybe one area where it can serve a purpose, or credits for disposing of refrigerants at end of life, because at the moment there's very few financial levers to use. Today, you can reclaim, you can reuse those refrigerants, which is fair enough, as long as you've got systems to put them into. But again, in 10 years, hopefully we've moved sufficiently across to naturals and low polluting refrigerants. So the refrigerants we've got today are not going to be able to be reused again in 10 years. So we have to destroy them basically. So that's a big challenge that's going to come. And it's one we're giving a lot of thought to. It's one that requires investment and resources. The processes and the technologies to deal with it are there today. We know how to process it. It's just nobody wants to pay for it. That's the challenge.
Largely because there are no economic benefits.
Yes, as I said, today you can reuse them. So if you extract refrigerant from a system today, clean it up, put it back into use, because you know that, okay, there's still going to be systems running for another 10 years. But I think in another 10 years or so, that option's not going to be there. So the one financial lever that exists today, which is sort of reusing the refrigerant, recycling it effectively, is not going to be there in 10 years or so. So it's going to become a straight up polluters pay type problem. In some places, they're tackling it. I'll sort of mention New Zealand, for example. They've got fees so that when the refrigerant is sold, there's ways of recouping, or let's say that money goes into dealing with the refrigerant at end of life. But those types of systems or those types of frameworks are few and far between. So we need more of those type of manufacturer responsibility or other financial levers to tackle that particular problem.
Right. I'm thinking again of your customers, and I'm just thinking of what you did at Teal and then what you're going to do here. So one of the things that you probably helped your customers invest in energy efficiency is that they saw the data about the saving that became sort of transparent, clear, easy to measure, and then they could invest from their own books, or they could perhaps get third-party investors. I'm guessing that was the case.
Yes.
But how do you see that play out in this new industry? Obviously, they will start measuring things, and then at some point you would say, okay, no, we need to replace this type of refrigerant. Do you see companies being able to sort of make those investments themselves?
Potentially, yes. For sure, as I mentioned, managing refrigerants, there's a big cost benefit, just in terms of the refrigerant replacement costs, the energy costs, but then, of course, the risk costs around safety and compliance, penalties and so forth. So you could still suggest it would pay for itself through those particular mechanisms. I think the other area that's interesting is to actually take a step back and think about what's actually needed, rethink the cooling process. Is what are we actually trying to achieve? Is there a better way to recover thermal energy, for example? Do we actually need this particular piece of cooling equipment in the first place? Can we do it with a district system using, Amory Lovin's integrated design principles? There's lots of ways to take a step back and actually rethink rather than just putting in another air conditioner or cooling system with refrigerant. I think things like cooling as a service or space as a service are really important concepts, because it puts the onus on the company delivering the service to have it absolutely running as well as possible. That's both from the refrigerants being used to the equipment being used. And that's where the type of tools, both from Teal and also Viridian, make sense, because they're supporting a service provider to be as absolutely efficient, cost effective as possible. That type of framework, I think, is one of the best things we can do going forward as well. Rethinking the need for cooling and then optimizing it, using as a service type delivery.
That's very interesting. We are coming to the end of the podcast. So I'm going to ask you, are you going to focus your business on the European Union or Singapore, or a bit of both?
So at the moment, we're looking at Europe and also Southeast Asia. Europe, perhaps a little bit more for, let's say, compliance-related work, and Southeast Asia across both, including training and capability building. In the absence of, say, regulation in Southeast Asia, I think there's a little bit more groundwork that needs to be done, but it's certainly where the bulk of the challenge lies. It's certainly the largest growth market for cooling equipment, so there's a certain urgency around that. So yes, we're focusing on both those regions at the moment.
And I find it surprising that there's so many companies who are building smart energy efficiency solutions in Singapore, right? I mean, it's such, as you said, very compact place. Just some final thoughts on why it has attracted so many entrepreneurs?
Yeah, absolutely. From my own experience, it's a great business environment. It's very transparent, fluid. It's easy to get your head around how things work. Even as I arrived there, I didn't know anyone, or had no network there at all, but it was a great place to start building up a network, met people like Ken Hickson and others who are very active in this industry. So for me, that was a great place to start. And I think that works for lots of other people. In the broader sense, I think people look at the building industry and you look at the number of buildings and the amount of energy that's consumed. And on paper, it's a bit of a no-brainer. You think, okay, there has to be fixes. There's so many buildings out there, and we know that traditionally they're not run at optimum. But there's also lots of challenges. Once you start to dig into that sector, you've got lots of layers of different contractors and stakeholders, and it's very difficult to navigate. A bit of a trap. There's a bit of a technology first approach, and we were perhaps guilty of that as well, is thinking that tech on its own is going to solve the problems, whether it's energy or controls optimization. And it's rarely the case. It really needs to be a people first, people orientated approach, and then finding the right technology fit to deliver the right insights to the right people. And I still believe that. And you can do that better as an independent. If you've written your own software and that's the only that's the technology stack you've got, then you're kind of forced to try and, even if it's a round hole, you're trying to sort of squeeze that square peg in. And I think sometimes that's at the detriment of some of the building owners, and also, we're ending up with these vertical silos rather than what we really need is a horizontal data layer to really serve the building operators and all the different stakeholders. So it's a really complex space. It's interesting because most investors understand software. They understand software as a service, subscription models. You've got lots of buildings. You can kind of sell that idea quite easily, but it's a little bit more challenging to actually make it effective, to actually get significant results out the other end. It can be done, but it's perhaps not as easy as it appears at the outset for those coming in from outside the industry.
Thank you very much. I want to wish you the very best in your journey with this new company. But before you go, is there any last thoughts that you want to leave for our audience today?
Perhaps one, if we're talking about refrigerants, while it's a big challenge and maybe one that most people aren't aware of, is everybody that is a consumer can still make a difference. So even if you're looking to buy a new air conditioner, refrigerator, or even a new vehicle, then you can make a decision based around what refrigerants inside. It's something that all of us can play a part in. I think if there's enough consumer pressure can also help solve this particular climate problem as well. So I'd encourage everybody to go in, perhaps ask those questions and do a little bit more homework. If you need some assistance, by all means, I'm happy to offer advice as well where I can. We can all make a difference when it comes to refrigerants.
We can all make a difference when it comes to the climate crisis as consumers.
Absolutely.
That's a very uplifting way to end the podcast. Thank you very much, Adrian Bukmanis.
And thanks again for the opportunity and having me on today. Thank you.